Hi, welcome to today's video. We will be looking at subject of the relation or subject of the formula today. When we're talking about subject of the formula or subject of the relation, it simply means the one expression that's on one side of the equal to sign alone. So in equation 1 here, A is the subject of the formula right now because A is alone and then we have B plus C on the other side. So we have A equals B plus C. In equation 2, we actually have ST squared minus V equals PU. So there isn't any clear subject of this formula right now because we have multiple expressions or elements on both sides of the equal to sign. But we can definitely make an expression the subject of the formula. All we have to do is do a little moving around. But before we get into that, I want to make something clear. When we're trying to make something else the subject of the formula, we need to remember our opposites. So, what am I talking about? I'm talking about the opposites of different mathematical expressions. For example, if you are asked, what is the opposite of addition? If you said subtraction, you are right. And also, that means that the opposite of subtraction is addition. What is the opposite of multiplication? It's division. What is the opposite of a power? Let's say power n. I hope you know the caveat sign represents power. The opposite of a power is the nth root. So if you have something power 2, the opposite of that would be square root. And if you have something power 3, the opposite of that would be cube root, and so on and so forth. Okay, so we're going to do two things. Remember that I said in equation 2 or formula 2, we don't have any clear subject. So how about we try to make T the subject? What does that mean for us? It means that we're going to try to move every other thing that's on that side to the other side. So we're going to move the S, we're going to move the V, and we're even going to get rid of the power 2 that's attached to the T because we just want T to stand alone. Okay, let's get to it. So this is what we have as our equation 2. S T squared minus V equals PU. We're going to have to work step by step, one after the other, in order to move everything from the left side to the right side and keep T alone. Now, the first thing we can remove is something that's more loosely attached, and that would be the V. The V is loosely attached to the other one because, as you can see, S and T are quite close together, but then V is separated by a whole subtraction sign. So we have to move V to the other side of the equal to sign. And remember our opposites, I already introduced them. What is the opposite of subtraction? That's addition. So it means that when we're taking V over to the other side, we have to change the sign to an addition sign. So we will have ST squared equals PU, because PU was there before, PU plus V. Now that's one step taken. The next step we need to take is we need to still separate whatever is being attached to T. Remember, we're working backwards, so we're moving the least attached element one after the other. So now between S and T square, S is S is not as attached to the T as the square is. So what we need to do is we need to remove the S. Remember, how is S attached to T? T square. It's attached using a multiplication. I just put that dot there so you can see it. It's a multiplication. And so we need to do the opposite of multiplication, which is division, when we're sending S over to this other side. So once we do that, we'll have only T squared. And on the other side, we'll have PU plus V all divided by S. So S has to divide every other thing that was already existing on that side of the equal to sign. That's how it works. And now we have T squared equals PU plus V all over S. Now we can get rid of the square. Now we can get rid of it. And how do we get rid of it? Remember, the opposite of something raised to the power is the nth root of that expression, right? So now we have T equals square root of PU plus V all over S. Congratulations, we have now made T the subject of the formula. By working step by step, we were able to move everything that was on the left side of the equal to the right side of the equal to sign. Let's do a second example to solidify the knowledge. All right, so this is equation 3. What do we have? We have V equals pi divided by capital R square minus small r square. Just for context, since there are two R's here, I think I'm going to name them. I'm going to give the capital R, let's do Raymond, because that's someone's name. It's a noun and it requires a capital R. And for the little r, I'm going to do red, because that's an object or a color. It doesn't require a capital R. So we're going to, when I say Raymond, you know I'm referring to the capital R. And when I say red, you know I'm referring to the small r. So this is our expression. And we are told to make Raymond the subject. All right. So the first thing we need to do is that we need to notice that on the right side of the equal to sign, there is a numerator and a denominator. And we can't have that. In fact, I'm going to write it in another way so you see it more clearly. It's pi all over Raymond square minus red square. So there's a numerator and a denominator. And we can't work with this. So what we need to do is we need to cross multiply. And obviously for this to work, we have to make the assumption, which is a correct assumption, that V is same thing as V over 1. So we cross multiply in order to bring everything to the same level. We cannot work with denominators and numerators. So when we cross multiply, especially because Raymond is part of that denominator, we then have V times Raymond square minus red square equals pi times 1. Okay, so remember that we are trying to free up Raymond, right? So the next thing that we need to do is we need to expand the bracket because Raymond is still inside the bracket. We need Raymond alone. And that gives us V Raymond square minus V red square equals pi. Remember, to expand the bracket, we have to multiply everything that's outside the bracket with everything that is inside the bracket. What we have now is much easier to work with. Look at the second expression, V red square. There's no Raymond there, so we don't need it on that side. We don't need it on the same side with Raymond. So we can move it to this other side of the equal to sign. And remember, right now it's connected to everything else with a subtraction sign. So when we're moving it, we'll change it to addition. So that gives V Raymond square equals pi, because pi was there first, plus V red square. Now V and Raymond square are connected using multiplication. So it means that when we want to take V to the other side, we have to do it with division. That gives us Raymond square equals pi plus V red square all over V. And lastly, we can now get rid of the square that's attached to Raymond by taking the square root of the other side of the equal to sign. And that gives us our Raymond. Raymond is free equals the square root of pi plus V red square divided by V all over V. Now, if this is a multiple choice, if this is a theory question, this is a very good way to keep it. But if it's a multiple choice question, you might not see it exactly like this. So you might see it as Raymond equals the square root of pi over V plus V red square over V. And obviously with V cancelling V, we'll have pi over V plus red square. Congratulations, you have successfully made Raymond, capital R, the subject of this relation. Thank you for watching this video. I hope you enjoyed it. If you have any questions or need direct math tutoring, feel free to email us at durotutors@gmail.com. I'll see you in the next video, and until then, keep durowing.